It's an exciting time right now, dealing with multiplying binomials by polynomials with an area model. Make sure you have this beautiful rectangular looking thing in your journal. It's going to be super, super easy. If, and only if, you know how to find the area of a rectangle. Does anybody know the formula for an area of a rectangle? That's right, just length times width. Or sometimes it's referred to as the base times the height, okay? Now, here we've got four beautiful little rectangles. They're beautiful, they're pretty. And all we got to do is multiply this monomial by this monomial. Now, what's the coefficient right there? A 2. Even though we can't see it, what's the coefficient right here? 1. And 2 times 1 is 2. Now, what are we allowed to do with this exponent right there and right there? We're allowed to do what? Add them, so we get what? Y to the power of 6. Very good. Now, hopefully you'll be able to see my blue. Yep, looks like it works. Okay, so we have 2 times 6, which is 12. Now, this is y to the power of 3, also known as y cubed. And this is y to the power of 1. Don't forget it. It's still there. Yes, 12y to the power of 4. Beautiful. Good job. All right, now, we've got a 5 times a 1, and that's a 5. And that's y to the power of, even though you can't see it, that's a 3. That's y to the power of 3. So this is 5y cubed. And we got 6 times 5. And 6 times 5 is 30. And then we got y to the power, what is that? Y to the power of 1? Y to the power of 1, so that's just 30y. So just remember, if you don't see a power up there, assume there's a 1 up there. That's where students mess up. Now, y to the power of 6 can only be added to other y to the power of 6. So there's none. There's no like terms. Can you guys see? We got 6. We got what? A 3. We got a 4. We got to put it in what form, though? Standards. We got to go from like the highest exponent down to the least exponent. So this is what I'd have to carefully write. Nice and neat. Into the Khan Academy. And then and only then will you get the answer correct. Whew. All right, here we go. See. All right, so here we go. Type it in. What did we start with? We started with a 2y. Oh, I got to scroll down a little bit. Sorry. 2y to the power of 6. And then what do we have? Plus 12y to the power of 4. Then plus 5y to the power of 3. Then 30y. I double check it just to make sure I didn't screw up, because I screw up all the time. Just ask my wife. All right, bunch. All right. Ooh, it's a good man. Okay. Oh, guys, put this one down. All right. The reason why I want you guys to put this one down is this one is a trinomial multiplied by a binomial. So here's the binomial right here. There's the binomial. This is the trinomial, and I want you guys to build this chart nice and neat. Just all right, build it nice and neat, and we will go over it in just a second. All right, so here we go. We're going to find the area of each of these little rectangles, and then we're going to add only the like terms together. So remember, this is x to the power of 1. So what is x squared times x to the power of 1? That's x cubed. All right, now we have x times 3x, which is 3x squared. 2 times x is simply a 2x. 4 times x squared is 4x squared. 4 times 3x is a total of 12x. 4 times 2 is 8. But now what do we have to search for? We have to search for like terms. So pay very close attention right here as I highlight. Can you guys see how these right here? Those are like terms. Right here, you see these? Those are also like terms. So here's your final answer. X cubed plus, what's 3 plus 4? It's a total of 7. Do you guys see that? The 3x squared and the 4x squared gives you a total of 7. 2 plus 12 is a total of 14. So it's a total of 14 x's. And what do we add at the end? Add in 8. So this one is a little bit trickier because the first one, did we have any like terms? No. Listen, If I have an x squared, I have students like, do you don't add the x? No, we don't add the exponents. If I have x squared plus x squared, that is actually what's called 2x squared. But here's where students need to remember. If I have x squared times an x squared, that's x to the power of 4. So you need to know the difference. Like when you're adding, you're just adding the terms together. But when you're multiplying, that's when you add the exponents. Okay? You bet. So we're going to type this in, nice and neat. All right, so we had x to the power of 3. Then I believe we had, what, plus 7x squared. And then there was, what is it? Plus 14x, and then plus 8. Okay. So looking back, there we go. Yep, we got everything nice and neat. Boom. So it looks like I'm not going to do, by the way, guys, on this one, you do the same thing, okay? I'm going to go on to the next one. Since it's all positive, I'd like to get one that maybe has a little bit of negatives in it, okay? But you just do what? You multiply and then add the like terms together. All right, so here we go. Multiply binomials by so this looks a little bit differently. So what I'd like you guys to do right now is write this problem down. This is the next section, all right? This one, you can do it 2 different ways. So we're going to do it 2 different ways, and you can do whichever way that you like. All right? So the first way we're going to do it is we're going to do it the way that I was taught way back in the day, a long time ago, decades far, far away. Oh, hold on. That's an x squared. No, no, it's not the Jurassic area. Time period. Era. Not area. Era. There we go. Yeah. That's what happens when you hang around high school students all day. All right, so here you go. So here we go. Right now, we're going to multiply x times x squared, and that gets me x to the power of 4. We got x squared times a negative 6. That gets me negative 6x squared. Then I'm switching over here. Remember, that's the first term. Now I got to do this term right here. 4 times x squared is 4x squared. Then we got 4 times negative 6, which is negative 24. Do you guys notice what I did there? I kind of put these right next to each other because they're like terms. So now we just combine the like terms. So we got x to the power of 4 minus 2x squared minus 24, and you're done. That's it. All right, so listen, that's the same thing. So listen, if you like the other way, could you set it up the other way? I'll put the other way right here, okay? It's kind of, you could make a what? Make a model out of it if you like the model. Well, how do you know how to make the model? Well, it's a binomial times another binomial. So you put the x squared here and the 4 here. You'd put the x squared here and the minus 6 there. Then you do the x squared times x squared is x to the power of 4. X squared times negative 6 is negative 6. X squared 4 times x squared is 4x squared. 4 times negative 6 is negative 24. And then what do you have to make sure you do? Combine the like terms. So what did we do before? We did the what? Area model. Now you're just doing it without the area model, but could you still set it up in the area model if you like that method? Yes. So we're going to go ahead and type this in now. We got we're starting with what? X to the power of 4. Then what do we have? We have minus 2x squared. And then we have minus 24. All right, that's it. All right, so for those of you who already feel confident, you're more than welcome to go on your own. I'm going to do one more problem, but I told you what we're going to do on this one is we're going to build it in rectangular. We're going to make a model out of it. Okay, so I'm making the length for the trinomial. There we go. And then I'm going to make just a couple of more sections. That's not too bad. There we go. Okay, so here's my rectangular model. That says c squared, so I'm going to put c squared. That says minus 6, I'm going to put minus 6. Here I have a 2c squared plus 3c minus 1. I realize this takes a little bit of time, but if I only had 4 problems to do as a student, I'd be like, I'm just going to take my time, do it right, and get done with it versus make one little tiny mistake and have to redo it. So right now, once you have it all set up, I'm going to pause it real quick, give my students a chance to set up. All right, so what we're going to do is we're going to take c squared right here. We're going to multiply it to 2c squared, and that's going to give us 2c to the power of 4. Boom! Sorry, thought of c4 there. Okay, and then we got 3c times c squared, and that's just 3c cubed. Now here's where students mess up. They forget there's supposed to be a power of 1 there, and 1 plus 2 is 3. And c squared times a negative 1 is a negative c squared. Okay? Negative 1 times c is a negative c squared. 2 times negative 6 is negative 12, but we got to put the c squared right there. Then we have 3c times a negative 6, that's negative 18, but there's still a c to the power of 1, so we still put c. Then we got a negative times a negative, which makes that a positive, so I'm going to put a plus 6. Now what we have to do is we got to scan for like terms. Scanning for like terms. Well, the only thing I can see that are like terms, I got a negative c squared, and I got a negative 12c squared, and that's it. So here we go. Here's our final answer. 2c to the power of 4 plus 3c cubed. Now I got to combine those. So if I've got a negative, even though you can't see it, that's a negative 1c squared minus 12 more c squareds. That gets me negative 13c squareds. And then minus 18c plus 6. Woo! That's a big old long bad mamma jamma right there. All right? And we got to take our time. You notice I'm not rushing through this because I actually want to get it right. Okay? So I'm going to type that in now. Here we go. 2c to the power of 4. And then I go and I look what I got next. Plus 3c cubed. So I put plus 3c to the power of 3. All right. Minus 13c. Was it c squared, I believe? Minus 18c plus 6. There we go. So there's everything written down nice and neat. I think we're ready to go. Let's go ahead and check it. Boom. 2 questions done. Keep going. All right? So here's my suggestion. Whenever you get a trinomial being multiplied to a binomial, my suggestion is this. Build yourself a nice rectangular model to be able to multiply and then add the like terms. All right? So good luck and get this done.